May I continue? Dr. Abhishek, may I continue? Are you still there?
Yes, sir. You're audible and visible, sir.
Okay, I should continue?
Yes, sir. Yes, sir.
Okay, fine. So, and I should turn off my video?
Yes, of course, sir. If you want that one,
Okay,
that's fine,
okay,
sir.
okay. That microphone is now working. Okay. And when I change the slide, please see whether the slide is being changed or not. Just see this. It changing?
Yes, sir. It is changing, sir.
Fine. So I start formally. Okay, good evening, everybody, the participants as well as the faculty members. Dr. Abhishek, I start in that particular recent trends. I have chosen this particular design and optimization of MEM sensor for biomedical application. This has been done by one of my PhD students, and that is what I am presenting. Hot topic of biomedical application. Fine. This is the introduction to sensor. This is the outline. Introduction to sensors, classification, characteristics, then what are gas sensors, and in that gas sensor also VOC sensors and their design challenges, their modeling, simulation of solidly mounted film bulk acoustic resonator sensor for VOC detection. Volatile organic compound. These are the gases which needs to be sensed in medical applications and some factories as well, from industries as well. Then second last is optimization of these particular sensors, and then optimization of that flexible SFM bar sensor, conclusion and references. This is the outline, brief outline of my talk. So a sensor is basically a device that detects or measures a physical property and records, indicates, or responds to it. So this is a physical quantity on the left hand side. Is the pointer also available? Is visible? Fine. The physical quantities may be force, pressure, humidity, temperature, etc. These have to be sensed, and this sensing using a microsensors. There is nano sensors basically sensing the physical phenomena, and then that converts that into an electric form. And electric form is basically voltage, current, frequency, etc. So these MEMS are basically miniatures, mechanical and mechanical functionality. It converts a measured mechanical signal into an electrical signal. These are the brief classification of those sensors. What has to be measured is acoustic, electrical, or optical, or biological, magnetic, chemical. These are the measurements basic. And the energy and or the power, they are to be measured with the help of these thermistors, strain gauges, they may be capacitive, they may be inductive, or they may be passive as well, thermocouples, piezoelectric, or photodiodes. Then that signal conversion of biological and physical and chemical processes also has to be done. Okay, so this has to be done in physical. Then their applications are varied, starting from agriculture to automotive engineering to domestic appliances, a huge number of in defense, space, marine, all these things. Right? So we will be seeing some of the parameters which have to be observed, the sensors also need to be optimized, and then we will be comparing it with the present sensors. Fine. So the sensor characteristics, just a brief overview. You define the same thing as you have done in measurements courses: the accuracy, the precision, sensitivity, resolution, repeatability, selectivity, and drift. Okay, these are the static characteristics. The definitions, all of you are the faculty members. You know what do you mean by all of these things. And in these sensors, this repeatability is a good is a issue uh, which results in a low cost of these particular sensors. The resolution is also very good, sensitivity. They are very sensitive, precise, accurate, and their drift is also less in comparison to the other sensors which are existing. So these nano sensors prove to be a good thing. Right, the dynamic characteristics which have to be noted for these for these sensors are rise time, delay time, peak time, the same thing as for any other sensors. 10 to 90% of that thing, you call that as a rise time. Delay time is 50 time to reach 50%. Peak time, settling time, percentage overshoot, and steady state error. These are all as have to be found out for these particular nano sensors as well. So I start with this gas sensors. Basically, this is the target gas, that is the VOC sensors, volatile organic compound sensors, that they are targeted over this particular sensing layer. The environment which has got an oxygen that along with that particular thing leads to some sort of adsorption, maybe some small sort of desorption is also there after reaction. Okay, and that this particular absorption, after this adsorption and desorption, you have some change in physical properties. That may be change in mass, change in density, temperature change, conductivity, or the optical properties or the work function. This is the basic gas sensing mechanism for these nanosensors. These are some of the traditional MEMS based gas sensors. One are acoustic, organic or inorganic films. The sensing principle is mass, density, change in the or change in frequencies. Calorimetric, then maybe this is catalytic field effect sensors. Then that are catalytic materials. So you have electric field change in this. So lot many, so some 10 number of sensors have been defined in this, ending with optical sensors that senses the optical light. That is that those sensors will be photodiodes or light sensitive materials, and light modulations will be done. This we can easily then use with the traditional devices which we are having. Fine. Opticals are now coming up, so optical amplifiers are there. Optical sensors can also integrate with the existing devices. The key challenges in gas sensor design is detection of very low concentration, that is dangerous to human health. That has become a challenging task for upcoming gas sensors. So see the thing, it is a very low concentration agents. You cannot sense it like that. Means the concentration are not high, and you have to detect that. But it is dangerous for human health. So this is one of the key challenge. Electroacoustic transduction mechanism based sensors possesses a high sensitivity to sense various biochemical agents based on VOCs. That also is a challenging task. Then design and development of a portable. So these first two are basically simulation studies which we do, and then finally a hardware has to be made. A design and development of a portable, cheap, highly efficient, and easily employable chemical sensors with flexible technologies, and that integrate with the existing technologies. That has to be done with the by the researchers and the industries. So now this is volatile organic VOCs. This is highly reactive or toxic organics radiated by either man-made sources or natural sources because of their high volatility under atmospheric conditions. Under atmospheric conditions, fine. So this is in medical or industries field, and they work without any higher pressure. Also, it is under atmospheric conditions. Also, gas emitted from certain solids or liquid, they are called.
I think due to network problem, he might have left. He'll be back in a minute.
Be done by.
Sir, I think you have been logged out accidentally, Hassan.
नहीं, मैंने चालू कर दिया, माइक चालू कर दी, हो गया चालू। आगे और शेयर वाला, एक मिनट, शेयर वाले देख लेते हैं। शेयर वाले में विंडो, और ये शेयर करा, शेयर करा। इज इट विजिबल? आ गया ना? आ गया ना? हाँ, सो आई स्टार्ट विद दिस स्लाइड ओनली, वीओसी सेंसर। फाइन। सो दिस वाज मिसिंग, मैंने इससे पहले वाला ही मिस हो गया था क्या? नहीं, यहीं से चालू कर दूं? ठीक है। तो वीओसी सेंसर्स आर, ओके, मैं फोन कट कर देता हूँ। These are analytical devices that consist of a biological sensing layer and a transducer, a combination, in fact, over here. And application areas, I've discussed in the previous slides. They measure gas concentration, very low gas concentration, and provide an output for an emergency action. Key challenges in VOC sensor design is detection of very low concentration agents. It is microacoustic transducer. My One of my students has done it using this translation mechanism, and that possesses high sensitivity to sense biological chemical agents, biochemical agents based on VOC. That is a challenging task. And then design and development of these things or a flexible as a flexible. Right. These are various sort of sensing mechanism. One is optical, one is calorimetric. Again, whatever we have given it in this slide, in the table, that is in a form of a chart over here of the sensing material. Here, the last two ones, the surface acoustic wave and the bulk acoustic wave. These bulk acoustic wave sensors is basically a film bulk acoustic wave and the solidly mounted film bulk acoustic resonator that has been studied with by one of my students. And the frequency, the resonant frequency which we have to find out is given by this particular equation: bulk acoustic wave velocity upon 2 tp. Tp is the thickness of this particular piezoelectric layer. So we have a piezoelectric layer on which this particular this basically produces a change in